Electricity is an amazing thing, causing thoughts to occur, muscles to contract, all sorts of different things to happen within your body. And in this shocking episode of Mechanical Mashup, Dave's going to show you how to build a taser with more electricity to your body.
This is the most important disclaimer we have ever done.
If you build one of these things and you tase people on the street, you're going to jail. Don't do it.
Even if you just have this for personal protection, there are some places where you will still get in trouble just for having it. Check your local laws before building this. That being said, if you pull this out with a bunch of friends who've been drinking, now you've got a party. Now I swear this is a true story. In electronics class in high school, I was looking through a stack of papers for extra credit. And I was looking at all these things, and I saw one titled The Tickler, and the name made me look a little closer. And I realized that this was the blueprints for a taser. So of course I built it. Obviously the stack of papers hadn't been screened very well. So I'm walking down the hallway with it, and doesn't the principal come around the corner? And he startled me, so I shoved it behind my back. He must have seen the look on my face and known something was up. The exchange went something like this. What's that behind your back? It's just something I made in electronics class. What's it called? It's called a tickler. What's it do? It tickles? Okay, do it to me. Why are you even thinking about this? He asked you to do it! Do it. Do it. Do it. Do it.
What are you looking at me for?
Do it.
He's
Do it.
right.
Do it.
Do it.
Yes.
Do it. Do it.
Don't ever bring that to school again! Okay, for real. That was a true story. Now, granted, it was a long, okay, I'm really old, long time ago. Things have changed a lot since then. If you were to try something like this now, you'd more than likely wake up in a naked pyramid in Guantanamo Bay.
Dave doesn't have his old high school books anymore, so he went online and googled do-it-yourself taser. Sure enough, a few schematics popped up. He liked this one. The trick is now to redraw the schematic as a circuit board. The problem is the pins on the IC end up being different in spots, so it ends up looking different on your board. We don't know why they do this, but whatever. Dave thinks figuring out circuit design is kind of like a cool puzzle. Print out the trace pattern you can find in the PDF on our Mechanical Mashup page. If you don't have a laser printer like Dave, just take it to your local print shop and have them photocopy it onto acetate with the darkness set as high as it will go. Inkjet printers will not work for this. Dave put the tickler logo on there to show you which side was the right way up. It will print backwards from your printer, so when you transfer it to the copper board, the word will look and read right. Okay, so let me do a quick lesson on transformers. No, not that kind, this kind. Most people understand that if you apply voltage to a coil of wire, you get an electromagnet, right? But did you know that moving a magnet over a coil can create voltage? Of course you did, but if the magnet's not moving, no voltage is induced. This is important to remember. Now, if you place another coil with twice as many turns nearby and apply voltage to the small side, you get double the voltage on the other side. But see what happens when the input of the voltage is constant? The output drops off, just like when the magnet was not moving. When you fluctuate the voltage, you get an output. This is why we can't just hook up a 9-volt battery to a transformer and expect it to work. Now picture what would happen if your secondary coil was 150 times larger, like an articular, and if we apply the fluctuating voltage, ouch! Class dismissed.
So now we have to put the design of our circuit onto a circuit board, and we're going to do this by chemically etching, but you already know how to do that, right? Right? Because you've watched episode 7 where I made this out of brass. It's the exact same technique, okay? For those of you who haven't watched episode 7, you don't need to pause it right now and go back. You can get further details later, and I'll give you a really brief tutorial and a quick montage right now on what I'm doing.
Steel wool the copper to clean it, even if you just pulled it out of the bag. Try not to get any fingerprints on it. Oils from your fingers will affect the transfer and the edge. Transfer the image with an iron on full heat and use a sheet of regular paper on top so the plastic won't melt into the iron. Careful, because the copper gets really hot and stays that way for a while. Peel off the acetate and you'll have a trace pattern. If there are any spots where it did not transfer well, touch it up with a permanent marker or some paint. Soak the board in your etching solution. Make sure to use plastic containers as the chemical reacts with metal. After about 15 minutes, pull it out, rinse it off, and wash it with acetate to remove the marker and toner.
Alright, welcome to Quick Tips. Today I've got my good friend Lisa Farrows here, and we're going to show you how you can tie a person to a tree without using any rope at all. So Lisa, I'll get you to help me out here. Just, yeah, you gotta put your legs around the tree and move forward a little bit. If you're doing this to a guy, they're going to think this is a practical joke and you're going to grab their legs and yank on it and hurt them, but you're not. Put the one leg up underneath, the other leg underneath your butt. And you slide down a little bit. Give it a little bit of a push. So the size of the tree is pretty important here. Too small and they will be able to wiggle out. Too big and you actually put a lot of pressure on people's joints, so you got to find a good balance. You could use a signpost for a street sign, not the little steel ones, but the big wood ones. You could use a soccer post if you wanted, but trees are awesome. They work very well.
Mommy!
And they are locked in place. How do you feel, Lisa?
Like I love this tree?
Can you get out?
Not really. More yoga classes.
Now when you want to get them out, it's easy just to put your arms underneath their armpits and pull them up. But that's of course when you want to get them out. You may want to extort some money or get something out of them beforehand.
Cut out and tape the whole template in the PDF to the circuit board. Use a center punch to lightly mark through where you'll be drilling the holes. Now carefully drill all the holes in the required spots. The sizes are indicated on the PDF. The bits are small, but you should be able to find them in the Dremel section at your local hardware store. Insert all your components in the required spots and solder them into place. Just gently hold the iron against the board and the lead. At the same time, wait a few seconds and touch the solder to the lead. It will flow around everything if it's hot enough.
Okay, so here's our circuit board. You can see the battery is taped onto the back of the board, and our switch goes into our casing, which we're going to use the flashlight. So this here is our final product. You can see I put it into a flashlight. I chose this flashlight because everything fit nice and easy, and I had it on hand and it was cheap. So you can use whatever case you want. You can probably find something quite a bit smaller than this, but this is what worked for me. You can see our leads on the business end coming out here. I didn't use this switch here because I was worried that if you turned it on, one, you'd get accidentally shocked, and two, you'd drain the battery. So this is a switch from our circuit here, this red one. When you press it, it turns on. When you let go of it, it automatically turns off. Now, this isn't really so much of a taser or a stun gun, as really it's more of a cattle prod, just to give you some pain. It's more voltage than one of those barking dog collars. It's more voltage than an electric fence. We're running at about 1200 volts or so. A real taser runs at about 10,000 volts, and that's what you need, at least 10,000 volts, to really affect the central nervous system and lose control and even pass out sometimes. But we're not going to go that high in this episode. Now, I had a lot of trouble trying to find someone to help me test this thing out. but maybe you guys can help us out. If you build one of these, you can post the video on our Facebook page. Ow! So that never happens again. I am going to get rid of that evil little thing.
You're gonna get rid of the taser?
Yeah, I guess I could do that instead.
Oh, okay.
I'm going to send it to Ben and see what he can do with it.
The SWAT team agrees to demonstrate what a single taser gun would do. And for the first time on Deadliest Warrior, the test victim is a living man.
Tim, are you ready?
I'm ready.
Rick, are you ready?
Ready.
On 3, 2, 1, tase him, bro! Oh, jeez, man.
So at Mechanical Mashup, we've been really lucky that Dave Spencer, myself, and a guy from Spike TV, the Deadliest Warrior, Jeff Demelin, all happened to be in the same military unit way back when. So I got a hold of Jeff, and we're going to talk to him about some tasers. So come on in, Jeff, and we'll chat about it.
Ben, what's up?
You gotta work on this.
What
is differential going on here, or what? Is that your point? Are you sure that's still high enough? I'm still chopping my head off.
Oh, dude. Okay, so as you might notice, Jeff's, well, he looks a lot smaller on TV than he is in real life. So thanks for helping us out here, Jeff.
No problem, Ben. Glad to be here. And one thing I like to explain to your Mechanical Mashup crowd is the fact that I did actually do a lot of tests on that taser before we actually used it on the man. And there was a concept that I wanted to get across to these guys that never actually made the show. So I'm going to go through those points today. And that is one of being very, very simple if you know anything about electronics, and that's Ohm's law, right? V equals IR, right? So what is the purpose there? And these guys are made with whole different types of potentials, okay? This one here happens to be 1200 volts. You've got other standards about up to 10,000 volts, and then the X26 that we actually used on the show has a potential of up to 50,000 volts. Now, why would you find such a different amount of potential between different tasers? Well, that's because you only use a small percentage of that potential, okay? And it only pushes the current that you need, and that's about 5 milliamps to get the job done, okay? And the idea on the police tasers is that you need that 50,000 volts in case those two probes don't cleanly insert themselves inside the skin. If they do, you're only going to use about 800 to 1,000 volts, okay, of that 50,000, and in order to push that 5 milliamps. If, say, we have an example where, you know, one probe makes it into the skin and the other one gets caught in a leather jacket, for example, that's going to push the resistance way up, okay? And that's when you start to use that higher percentage of the 50,000 volts. It might get up to 10, might get up to 20,000, I don't know, whatever that resistance is. You have the potential there to push that current. And that's why these things are so safe but effective in a whole bunch of different types of scenarios.
Cool. So, like, what would the physiological effects be when you get hit by a taser? Am I going to crap myself, or, you know, wet my pants, or pass out? Like what?
I mean, that's all possible, but essentially what you're doing, and another name for these devices is neuromuscular incapacitation devices. So what they're doing is they basically disconnect your muscles from your brain, because you know your brain you know, controls your muscles, okay? And it does that by sending electrical impulses. Well, guess what? This is an electrical impulse, right? And we just give it directly to the muscles, get them to lock up, essentially full contraction, and you lose control of your body, and that's why these guys go down. So if I press this button right here, basically what that does is it engages this the whole electronics inside and allows that potential to realize itself at the end of these two probes here. And one thing I didn't get to do on the show was actually hit somebody with it. So,
What?
It works, doesn't it?
Thanks, Dave. Thanks. Yeah.
Now, the difference between this one and the one that we used on the show is as soon as you retracted, the electrical potential, you know, and that current that you felt disengaged, right? The X26 stays in you, and in fact, I don't know if you saw on the show, but there's actually an actual barb. So it's actually very difficult to remove from your body once it's inside it. And that's because if these guys do start flailing around like you saw on the show, you still can control them. And those pulses will last about 5 seconds. But after that 5 seconds, if he still wants to be a bad guy and still wants to be confrontational, you just hit him again.
How about you tell everybody like your website, how to get a hold of you on Twitter, and as far as I know, you also sell some T-shirts on your website that I think are pretty checked out. So.
Hell yes. My T-shirts are a lot of fun. It's basically, the whole concept is where science and violence meet. That's the whole concept of the designs. And so my first design is the science behind getting shot in the head with an AK-47. It was pretty cool. We have the blood and no blood versions to go along with that gratuitous violence. And you can check them out at www.jeffdamelin.com. But also I gotta, hit up my buddies as well. Max Geiger's got a site, giantsparrow.com. He's working on a game there. Also the doc. I believe the website is drinkdocs.com, and that's his drink, and it's been really, really successful. Been picked up by a few department stores and grocery stores and stuff like that. And this is what we do, in our day jobs when we're not being a doctor or being an engineer or being a game designer.
Thanks, man.
You bet, man. Take care of yourself.
Hello? Hello? Dave? Anyone? Hello? Somebody? This trick really works. It's not quite right. No.
Dude. Come on, man. I can't do this on the show. This is the internet. We can get away with anything.